Assalamualaikum and a very good morning to everyone, especially to our dearest Professor Dr. Noor Aizah binti Samad. So now our group will be present the group assignment SMS3013 Introductory Statistics. We choose the topic as our title is Variation in Daily Eating Patterns among the university students. Before we start, may I introduce our group member first. So we start from Nur Alisa Sabrina binti Abdul Manaf, Nurul Shazwani binti Rozaini, Alia Kristina binti Nur Izwan, and the last Nurul Fatul Fazli binti Muhammad Saufi. So first, healthy and balanced nutrition plays a crucial role in supporting both physical and mental well-being. However, the eating patterns of students tend to vary due to factors such as financial constraints, irregular meal times, and food preparation methods. By analyzing this data, we can gain insights into how these factors influence students' food choices and how such differences impact their overall lifestyle. This is our objective, which is to evaluate the variance in students' preference between cooking and buying at cafe, to compare mean money spent on food between cook versus cafe by using hypothesis tests in two populations, to compare mean breakfast, lunch and dinner by using one-way ANOVA, and the last, to determine if there is significant association between meal times and spending level by using chi-square distribution. Next, sample and population. To conduct this investigation, we designed a Google form to serve as a data collection tool and share it among students at University Pendidikan Sultan Idris. The primary objective was to gather detailed information about their current spending habits and financial behavior. After distributing the form, we successfully received response from a total 28 students. This group of participants provided valuable data, allowing us to analyze and understand the financial expenditure patterns of university students in today's economic climate. The significance of the study. This study examines the daily meal spending habits of UPSI students, comparing costs between cooking at home and dining at cafes. By using hypothesis testing, one-way ANOVA and chi-square distribution, it analyzes spending difference across meal times, breakfast, lunch and dinner, and explores the factors influencing students' preference. The findings offer valuable insights for students on budget management and for campus service providers to better align with student needs, ultimately contributing to more informed decision making and improved meal planning on campus. For instruments, this study analyzed the daily spending habits of students at University Pendidikan Sultan Idris, focusing on meal expenditures by comparing the cost of cooking at home and dining at cafes. Using hypothesis testing, one-way ANOVA and chi-square distribution, the research evaluates difference in average spending between these two groups and variation in expenditure based on meal times, breakfast, lunch, and dinner. Additionally, it identifies economic, social, and convenience factors influencing students' choices, offering meaningful insights for students' financial management and campus service planning, such as cafeteria operation and meal provisioning.
Calculating mean, variance, and standard deviation. First, we calculate sample mean for each meal time. Formula for sample mean is summation of x over n. Therefore, the sample mean for breakfast for all 28 students is Rm 1.79. Next, we calculate sample variance for breakfast. Formula of sample variance is n times summation of x square minus summation of x square over n times n minus 1. Hence, the sample variance value for 28 students is Rm 5.51. Next, we calculate sample standard deviation for breakfast. Formula of sample standard deviation is square root of variance. Then, the sample standard deviation for students that breakfast is Rm 2.35. We use the same formula from previous slide to calculate for lunch. Therefore, the sample mean lunch for all 28 students is Rm 6. Hence, the sample variance value for 28 students is Rm 11.63. Then, the sample standard deviation for students that lunch is Rm 3.41. We use the same formula from previous slide to calculate for dinner. Therefore, the sample mean dinner for all 28 students is Rm 4.57. Hence, the sample variance value for 28 students is Rm 12.70. Then, the sample standard deviation for students that lunch is Rm 3.56. This slide shows that the value of n, mean, standard deviation, and variance in a day between breakfast, lunch, and dinner by using Jamovi.
Next, second objective is to compare mean money spent on food between cook versus cafe by using hypothesis test in two populations. So let test at 5% significant level whether the mean of student cook is different from the mean of student buy. For cook, sample size is 31, sample mean is 3.74 and standard deviation is 2.4217. For buy, sample size is 34, sample mean is 6.35 and standard deviation is 3.5495. Hypothesis test have 5 steps. Step 1, state the null and alternative hypothesis. Null hypothesis is mu cook more than mu buy. Alternative hypothesis mu cook less than mu buy. Step 2, state the distribution to use. Because both of the sample size is more than 30, we consider the sample size are large and the sampling distributions of S bar 1 minus S bar 2 is approximately normal. Use normal distribution to perform hypothesis test. Step 3 is determine the rejection and non-rejection region. The significant level, alpha is equal to 0.05. The less than sign indicates that the test is left tail. Critical value of that is negative 1.64 as shown below. So, if less than negative 1.64 is rejection region and more than negative 1.64, we do not reject hash null. Step 4, we need to calculate the value of test statistic, which is we have formula for z equals to x bar 1 minus x bar 2 minus mu 1 minus mu 2 over standard deviations of x bar 1 minus x bar 2. So before that, we should to find standard deviations of x bar 1 minus x bar 2 and we get 0.7482. For the z value is negative 3.4886. And the last one is step 5. Make a decision. The value of test statistic is negative 3.46 is less than critical value. Z equals to negative 1.64. It for the rejection region. So we need to reject null hypothesis and conclude that the mean of student cook is less than the mean of student buy at the cafe. Next, hypothesis test about the mean of student who prefer to cook or buy by using Jamovi. After conducting an analysis to investigate whether the mean of student who prefer to cook is greater than buying, we utilize both manual calculation and statistical software, which is Jamovi. The result obtained through both methods were consistent, strengthening the validity of our finding. The mean of money spending by UPSI student who prefer to cook RM 3.74 and the mean of money spending by UPSI student who prefer to buy is 6.42. We use normal distribution and found that the test statistic, which is negative 3.4597, is less than the critical value, which is Z equals to negative 1.64. This indicates a rejection of the null hypothesis.
For objective 3, we are going to compare the mean of money spending by UPSI student between breakfast, lunch and dinner by using ANOVA. For first thing first, we have to calculate the sum of x for 3 samples and we get 346. Next, we have to find sum of x squared for 3 samples. For breakfast, we get 238. For lunch, we get 1322 and for dinner, we get 928. So the sum of x squared for 3 samples is 2488. Okay, the number of meal time, k equals to 3 because we have 3 samples. First thing first, we have to state the null and the alternative hypothesis for step 1. H null is the mean of breakfast, lunch and dinner are equal. For H alternative, not all 3 means are equal. Step 2, we have to distribute to use what table? Because of we compare the mean for 3 normally distributed population, we use the F distribution to make this test. For step 3, we have to determine the rejection and the non-rejection region. The significant level is 0.05. A one-way ANOVA test is always right tail. The area in the right tail of the F distribution curve is 0.05, which is the rejection region. The degree of freedom for numerator is 2, for denominator is 81. From the F distribution table, we have to calculate the degree of freedom numerator and denominator, and we know that 0.05 is the area in the right tail of F distribution curve. The required value for F is 3.1504. The total for 3 value for sample is 84, and then we are going to calculate the value of SSB and SSW. For SSW, we can calculate that and we get 257.2381. For SSW, we get 805.5714. For SSD, we have to calculate the SSB and SSW, so we get 1062.8095. For the calculation of variance between sample MSB and MSW, for MSB, we get 128.6191. For MSW, we get 9.9453. So, we can calculate the value of statistic F by given the ratio of MSB and MSW. So, for F, we get 12.9327. For convenience, all of these calculations are often recorded in the table called ANOVA table. Step 4, we have to calculate the value of the test statistic. Based on the calculation, we get F equal to 12.9327. Step 5 is we have to do the decision. The value of the test statistic F equal to 12.9327 is greater than the critical value of F is 3.1504. It falls in the rejection region. Hence, we reject the null hypothesis and we conclude that the means of breakfast, lunch, dinner are not equal. In the other way, the 3 different meal time affect the mean ways to buy meal. The difference in the mean ways to buy meal of our 3 samples occur only because of sampling error. These are the comparing mean of money spending by UPSI student between breakfast, lunch and dinner by using a software. On the right side, we use Microsoft Excel. On the left side, we use Jamovi.
Chi-square test to determine the significant association between meal time and spending level. We have 3 spending level, which is low with range RM0 until RM3, medium with range RM4 until RM7, and high with range RM8 and above. The contingency table show all values needed. Step 1, we state the null and alternative hypothesis. H null is meal time and spending level are not related, while H1 is meal time and spending level are related. Step 2, we use chi-square's distribution to make the test. Step 3, we determine the rejection or non-rejection area. So degree of freedom is 4. From the chi-square distribution table, the critical value is 9.488. Step 4, we calculate the value test statistics for each categories. Based on the previous slide, values of x squared is 21.6334. Step 5, we make a decision. Since value of test statistic is 21.6334, is greater than the critical value 9.4489 and it falls in the rejection region. Hence, we reject the null hypothesis and there is strong evidence to conclude that the 2 characteristics are related.
In conclusion, the analysis showed that the average amount spent on breakfast is RM 1.79, lunch is RM 6, and dinner is RM 4.57. Breakfast has the lowest spending and variability, while dinner has the highest variability, indicating more inconsistent spending compared to breakfast and lunch. Based on the hypothesis test for 2 populations, it was found that the mean money spent on food when cooking is significantly lower compared to eating at the cafe. The one-way ANOVA test revealed that there is a significant difference in the mean money spent across breakfast, lunch, and dinner. The chi-square test provides strong evidence that mealtime and spending levels are related. This means spending levels vary depending on whether it's breakfast, lunch, and dinner.